Solving rational equations. So I taught this lesson already in class, but if you missed a lesson or if you just need a little more help, here it is. Alright, so we're going to have a procedure for solving rational equations. We're going to factor all the polynomial expressions. Remember, the rational equations we deal with are made up of polynomial expressions. Okay? Identify the common denominator, and it must contain all factors. Quite frequently, when I ask what is the least common denominator, all I hear are the common factors. Okay, so I'll talk about more of that when we do the example. We're going to multiply through by the common denominator. What happens is when we multiply through by the common denominator, we are getting rid of the rational expression. We are making it fractionless. Right? So we're going to solve the resulting equation, and it should have no fractions because we multiply through by the common denominator, and then make sure no answers the answers we found don't make the original equation undefined. And we'll see an example of that. Alright, here's example 1. So here's solve. Alright, so this is our equation. First we factor it. It doesn't factor much. X comes out. Okay, now, so what is the least common denominator? And the least common denominator is not x plus 1. It's x and x plus 1. So the least common denominator includes all the factors, right? So x times x plus 1 is included by this, and x times x plus 1 includes the x times x plus 1 includes this x plus 1. Alright, I know, sorry. Hopefully you get the idea, right? The LCD must include all the factors. Okay? Alright, so what we do is multiply each term by the least common denominator. So we multiply 2 over x plus 1 times that LCD, 1, this thing, times x plus 1, and 3 over x, that's this one, times the LCD. Alright, so when we multiply that, we really want to cancel first, or reduce the fractions. So here the x plus 1 is reduced, leaving me just 2 times x, or just 2x. And here, the entire denominator reduces, so we just have the minus 1. Okay? And here, only the x reduces, leaving me 3 times x plus 1. So it's equals 3 times x plus 1. Alright, go ahead and simplify that. So we're going to distribute the 3. That's the only thing we can do in the first step here. So it's going to be 3x plus 3. Alright, so all I did was bring that together. And now we're going to solve. So this is, hopefully you can do this. You get negative x equals 4, x equals negative 4. Then you need to check to see if this makes the original function undefined. Well, the only thing that would make the original function undefined, or I'm sorry, the equation, x equals 0 or x equals negative 1 will make it undefined. So that's not it. So that is my solution. The solution to this problem is x equals negative 4. Alright, this is a little more complicated, not too much more, but there's something to be factored here. Factor out the 5 from that, and factor x squared plus 3x plus 2 to this, right? 2 times 1 makes 2, 2 plus 1 makes 3. So that's an easy factoring. So what is the LCD? So LCD has to include the x plus 2, the x plus 1, and the 5, right? So it has to include all these factors. And that's our LCD. So we're going to multiply everything by this expression. All right, yeah, that's big, long, messy. All right, so you're going to multiply. And by the way, you don't have to actually write this stuff. If you can do this mentally, just make sure you're multiplying each fraction by this expression. So you can do this in your head. So it's, what is this? X over 5 times x plus 1 multiplied by this, right? So the 5, that part is going to get reduced. If you do this in your head, that's perfectly fine. So it's x times x plus 2, right? That's what's left, equals, and then here, x plus 2 gets reduced. So it's going to leave me 5 times x plus 1. And here, x plus 2 and x plus 1 get reduced. And by the way, order doesn't matter, okay? So you're going to have plus 5 times 1. That's it. Now, simplify this. Distribute where you need to distribute, okay? So x times x plus 2 is x squared plus 2x. Multiply the 5 over x plus 1, you get 5x plus 5. And you just have this 5 over here. We're going to move everything to the left side. Whenever you have an exponent higher than 1, you're going to move everything to one side, set equal to 0. So the 5x come over, subtract from 2x gives me the negative 3x. The 5 plus 5 is positive 10 on the right, but when I move it to the left, it becomes negative 10. Now go ahead and factor this, right? It's going to be, what are the factors of negative 10 and combine to make negative 3? That'll be x minus 5, x plus 2. Okay? Then set each factor equals 0 and solve. So what makes x minus 5 0? 5. Right? right? What makes x plus 2 equal to 0? -2. So those are my solutions. Now we must check to see if either of these make the original equation undefined. So 5 is not a problem, right? It doesn't make any of these 0. But -2 is a problem. If I plug -2 into this expression, I get 1 over 0. If I plug it into this expression, if that's 0, 0 times whatever over here, it's going to wipe it out. So x equals -2 makes the original equation undefined. So we reject it. So our only answer is x equals 5. Okay, so that's it. All right. So this is the procedure. Factor all the polynomials. Identify the common denominator. It must contain all the factors. Multiply through by the common denominator and reduce wherever possible. Solve the resulting equation. You should have no fractions at this point. And make sure no answers make the original equation undefined. Okay, or the factored version. I always go back to the factored version. Okay, so I hope that's helpful. That's it for today. Bye.